Alright, so we are going to be looking at implicit partial differentiation. So before we do that, let's kind of review implicit differentiation from last year. So let's say we have this function. Remember, we call these implicit because it's not explicitly defined. It's not like x equals or y equals. And we're asked to find the derivative of y with respect to x. So to do this, we are going to use our chain rule because these are both, neither one of these are constants, they're both variables. So we have to use our product rule here, and we would get the first, multiply that by the derivative of y, but we get 2y, but don't forget it is a chain rule, so because we take the derivative of y with respect to x, remember y is a function of x itself, and that's really why this works out. It's really saying like this, x times f of x squared equals 5. They both have x's in them. So that's why when we take this derivative, we're going to multiply by the derivative of the inside, and that's going to give us this dy dx plus the second, y squared, times the derivative of the first equals 5. Whoop, 0. Don't tell anybody I did that. That should be a 0 because it's a constant. So when we solve for dy dx, we should get negative y squared over 2xy. Now, we can even have a little bit more fun. Well, that's dy dx. What if we were asked to find dx dy? Well, in this case, notice we flip them. Now we're taking the derivative of x with respect to y. So when I take the derivative of x, my first is still going to be x. The derivative of y, whoops, that should be dx dy there. My derivative of y would just be 2y. Now it's already in terms of y, that'd be like dy dy, plus the second, y squared, times the derivative of x. Well, the derivative of x with respect to y would be dx dy equal to 0. So dx dy would become negative 2xy over y squared. So we can do this even with multiple variables. And now, we'll talk about that in a second, but where do we see this? Well, we saw last year with these with related rates. So imagine you have a hiker. He's hiking, okay, or somebody's climbing a mountain, I don't know, something like this. And we have a base here that is 3, and we have a height that is 4, and of course the length here would be 5. And let's say we wanted to find dy dt if dx dt was equal to 3 meters per second. So this is kind of what we saw, where we just can take the derivative with respect to any variable. So of course I can use my Pythagorean, x squared plus y squared equals L squared. Because L is a constant, right? This is just 25 right there. That's a constant. So let's say x is changing, y is changing, but L is we're going to hold L as my constant. And so when we take the derivative, we would get 2x dx dt plus 2y dy dt, and that would equal 0. Well, I can find dy dt. Remember, we're just taking the derivative of everything with respect to t. So it always depends, you always have to be careful what we're taking the derivative with respect to. So when we do this in multiple variables, so let's take a look at some examples in multiple variables. Except for using dx and dy, we're going to use our del d, and our del x, or our little d, little x. So for example, right here for number 1, we want to find the partial of z with respect to x. So only z and x are variables. Which in this case means that y is a constant. So we don't worry about that one. We only have to worry about the x and z's. So when I'm taking the derivative, I have x and z here. Now remember, these are both my variables. So when I take my derivative of x cubed y squared, z squared, I will have to use my product rule. The same thing for here. X, y, z, I will have to use a product rule right there. So when I take the derivative, remember, I'm taking the derivative of z with respect to x. So when I write out our first, we're going to get x cubed. The derivative of z squared becomes 2z. But remember, I'm taking the derivative of z with respect to x, and so I get my partial z with respect to x. Plus the second, z squared plus, well, the derivative of x is just going to become 3x squared, and it's already in terms of x, so we don't worry about that. Minus our product rule here. Now I'm going to keep the y, because my y is constant with the 5x, 5 and the x, and I'll just keep my z independent there. So when I take the derivative, I'm going to get the first 5x y to the fifth times the derivative of z with respect to x, which is my partial z with respect to x, plus the second, which is z, times the derivative of the first. Be careful, that's my variable. So the derivative of 5xy to the fifth would just be 5y to the fifth. Equal to, over here, take the derivative of x. X is one of my variables, so the derivative of x is just going to become 2x. Now remember, I'm taking the derivative with respect to x, so it's really dx dx. Plus, and that's just my constant, so that becomes 0. And I can simplify all of this. I get 2x cubed z times partial z with respect to x plus 3x squared z squared minus 5xy to the fifth, the partial of z with respect to x, minus, be careful, 5y to the fifth z equal to 2x. And then I can solve. The partial of z with respect to x is the following: 2x plus 5y to the fifth z minus 3x squared y squared all over 2x cubed z minus 5x y to the fifth. And there is our partial derivative. Now we are going to take a look at a shortcut for this later on, though. Not right now, though. We're too young for that. So let's go and try this one. We want to find the partial of x with respect to y. So in this case, we are going to treat z as a constant right there. So if we treat z as a constant, that means we only care about x and y. So I take the derivative. There's my x. I have a y in there, so I do have a product rule. The same thing right here, y and x in there. There's my product rule. Even worse, I probably have a chain rule there too. So when we take the derivative, ready? Again, this is implicit. We're not saying the partial of x with respect to y is equal to that. We take the derivative here. So my first function is x squared, and we're going to multiply that by the derivative of the second. Well, y is my variable I'm taking respect to, so that's just 2 minus, again, z is my constant, so that just becomes 0, plus the second, which is this 2y minus 5z, times the derivative of the first. Now be careful, I'm taking the derivative with respect to y. So that becomes 2x times the derivative of x with respect to y. Now it's still a derivative, we just call it a partial. Partial of x with respect to y. Equal to, that's a constant, 0, plus, okay, this is a product rule because my two variables here are x and y, and I'm multiplying them, so it's going to be the first y times the derivative of cosine, which is negative sine 6zx, times, don't forget the derivative of the inside. There's a chain rule right here. That just becomes, z is my variable, my constant, sorry about that. So we get times 6z times the partial of x with respect to y, plus the second cosine of 6zx times the derivative of y. I'm taking the derivative of y with respect to y, so that's just 1. Whew, it's ugly. Alright, so I'm going to clean this up. So I get 2x squared plus 2x times 2y minus 5z times the partial of x with respect to y equal to negative, I'm just going to factor out the negative, y times the sine of 6zx. Well, I guess I could put the 6z in front of there too, times 6z partial x partial y with respect to y, plus the cosine of 6zx. Alright, bring everything together. This looks kind of messy. So that's going to give me 2x squared minus 6. Sorry, I guess I should say minus. Let me start over there. 2x squared minus, bring over the cosine 6zx equal to negative, I'm going to bring the 6z out, 6yz cosine 6zx partial of x with respect to y, and that's going to become minus 2x times 2y minus 5z times the partial of x, the partial of y. And I can solve for partial of x with respect to y, and that's going to equal 2x squared minus 6 cosine 6zx over negative 6yz cosine 6zx minus 2x times 2y minus 5z. Alright, now that we're done with that, let's go and take the second derivative. I'm teasing. It's really not that bad. The algebra is kind of a nightmare on that one, okay? Alright, but take a look here. But like I said, they're really not that hard. All you're really looking at is what we're looking for. So I can have something very simple. X, y, z equals 3. And I want to find the partial of z with respect to y. What I'm saying here is these are my variables. So I do have a product rule. So very simple. I'm going to treat my x, which is my constant, I'm going to attach that to the y and leave my z independent. I'm only taking the derivative with respect to y. So when I look at the first, that's just x times y times the derivative of the second. When I take the derivative of the second, remember, if I have z equals like 5x or 5y, that's going to be dz dy. So when I take the derivative of z, I get my partial of z with respect to y. We call it partials here because we have more variables. So we're only looking at part of all the variables. Plus the second, z. Now the tricky part. If I'm taking the derivative of x, y, well remember x is my constant. So the derivative of x times y will just be x. Well, the derivative of y with respect to y, remember we're taking the derivative with respect to y, would really be partial of y over partial of y. We just don't ever write that out. Equals 0, and you can solve. Anyways, I hope you guys like these. Take a look at the answers if you need to, and I will see you all later. Bye-bye.